Hey guys, so today I'm going to be talking about trig identities, and in particular, the Pythagorean identities. And they're really short and simple, so let's just get to it. This is the unit pi from my previous video about the unit circle, and it's just there to help you visualize cutting it up into bits and pieces. And so I'm just going to use it for this example. It doesn't really mean anything. Okay, if we draw a radius here of 1, since it is the unit circle, and we extend this line down here to make a right triangle, and we call this x, right, because it is x and this is y. According to the Pythagorean theorem, a squared plus b squared equals c squared. And this is if you have a triangle like this, and a is one side, b is one side, and c is the hypotenuse. So in this case, it would be x squared plus y squared equals 1 squared, which is 1. Now if you remember, x, we call that cosine theta, right? So x squared is just cosine squared theta, and you put the squared like right after the cosine, like this. That basically just means this. So that cosine squared theta plus y is sine theta, so y squared is sine squared theta, so we have this equals 1. And that's our first Pythagorean identity. Now we have 3. And to get to the other two, all you have to do is divide by either cosine squared theta or sine squared theta. And I guess we'll just start with cosine squared theta. So if we just divide the whole thing by cosine squared theta, this becomes 1, right? And this becomes, okay, sine over cosine, what's that? Tan, right? So tangent, except it's sine squared theta over cosine squared theta, so it'd be tangent squared theta equals, okay, what is 1 over cosine squared theta? Yeah, okay, secant squared theta. Am I sounding like Dora the Explorer? I'm sorry, just want to give you a chance to answer. Okay, so that's another one, another identity, and you can reorder it because you mainly see it like this instead. Just move the tan squared theta to the other side. So that's the second one. And the third one, you just have to divide it by sine squared theta, so I'm just going to erase this part. Don't worry, I'll rewrite it again. I'll rewrite this too. Okay, so dividing by sine squared theta, you get this. So cosine squared theta over sine squared theta. What's cosine over sine? That's just sine over cosine flipped, right? So that's tangent flipped, so that'd be cotangent squared. Plus, this cancels out, 1 equals, what's sine squared theta flipped? Yeah, cosecant squared theta. So remember, you can just reorder it. It doesn't really matter when you're solving it, just whatever works best. So you could have cosecant squared theta minus cotangent squared theta, just moving that to the other side, equals 1. And that's your third one. So just to recap, your 3 Pythagorean identities are sine squared theta plus cosine squared theta equals 1. That's one of them. Secant squared theta minus tangent squared theta equals 1. That's the second one. And the last one is cosecant squared theta minus cotangent squared theta equals 1.